what I want to do is talk about this spanning tree algorithm. Okay, the algorithm is actually how something is done. So whereas we call it spanning tree protocol, this is everything we need to do to run spanning tree. We use the algorithm to actually figure out how it's going to be implemented. So we have to go, okay, let's make a loop-free topology, right? And so there is the first thing that had to happen when we have a series of switches. One thing to remember is that, again, a packet that is in the layer 2 state, it does not have a time to live. So once it goes to a switch and it gets broadcast out all the switch ports, it will keep going forever. Until that happens. So the loop-free topology is important in order to make sure that packets do not continually loop forever. But so in order for this to happen, we have to figure out if we're gonna hook some switches together, one of them has to be the boss. Right? And so that's what the root bridge is. And you can always think of it as it's the boss. Now we're going to simplify a little bit. You can see this information with the bridge ID and the priority and the system ID and the MAC address, right? We can look at those three. We're going to come back to that later. What I want to do is focus first on the MAC address of the port. Now, what we know is that those MAC addresses come and they're created from the manufacturer. We don't have any control over those in most cases, right? The switch gets plugged in and the MAC address is what it is. And so that is what we're going to see here. So these other components were implemented to give us a little more control um, over root bridge election. But we're going to come back to that later. And what we have just some switches. Now, this particular set of switches, I would not normally have this many um, switches all hooked up in a cluster, but this kind of represents a mesh network. And so what we're going to do is we're going to trace this down and we're going to see exactly what happens when we plug all these switches together. Again, the first thing we're going to do is we're going to select the root bridge. So that one will be the root bridge, I want to make sure you see that. And what we do is we look for the lowest bridge ID. In this case, what we're going to use as the distinguishing factor is the MAC address. We're going to look for the lowest MAC address, and we're going to say that's our root bridge. That's the one with the lowest bridge ID. Okay. So I look at this first digit, everything's a 0, right? Nothing wins. I look at the second digit, and it looks like 5 of the 6 switches win in that contest, right? So switch 2 is out, right? That's not the root bridge. Now I look at the third digit, and I got an A, I got a 0, I got a D, I got a B, I got a C. That is the root bridge because it has the lowest number. All of a sudden, all those other devices are tossed out, right? And we actually have the lowest value right here. If there had been 2 that had been equal, we would move on. It's just like alphabetizing a word. It works the same way. So we're going to say that switch 3 is our root bridge. So I'm just going to move this RB over here by switch 3. That way we know that it is the root bridge. Now what happens is every switch that is not a root bridge then elects a root port. Every one. So the first thing that happens is that this particular switch elects a root port, and it's going to be every port that is actually attached to the root bridge. Right. This one is attached to the root bridge, so it's going to be a root port. This one is attached to the root bridge. It's going to be a root port. And this one is attached to the root bridge. Now there's also another switch here, right? It is a root port also. In this case, because it is the only port that is connected to another switch, right? So it has to be the root port. So what I'm saying is, how do I get to the root bridge, right? I use the root port. The next thing we do after we've chosen a root port, every switch has a root port. Okay? The next thing we do is we create designated ports. A designated port is the port that is the actual port that can go to another switch and it's going to be on. So it's a funny way to think about it, but the designated port is just the port that remained on. Okay, we're not going to turn it off. By default, all of the ports that are on the root bridge are designated ports. So I'm going to move my D's over there to all those ports. And that D is for that port. And that D is for that port. Okay, and then any port that is connected to an end device also becomes a D. Right? So that becomes a D right there. Also, every port that is on the other end of a root port becomes a designated port. I need a couple more. D's. I don't want to run out. So this is on the other end of a root port. It's a D, it's a D, D, D. We're going to put a D right there. Okay. Now, the next thing we have to do is we have to look at the segments that do not have, that are not connected to the root bridge and that do not have a designated port on it. Right? In this particular case, there are two such segments, one here, and one here. Right? These are ports that are not connected to the root bridge, and they do not have a designated port on them. Okay. So I'm gonna actually look at that, and I'm gonna say, okay, I have got to figure out the lowest cost to the root bridge, and the lowest cost port to the root bridge is going to be the designated port. So I'm going to start right here, and I'm going to start looking at path. Now, the way that this works is in the standard, every time I make a hop, I multiply by 19. So here's one hop, two hops, right? So that's 38. Right? It's basically, what I'm really doing is I just count hops. Okay, so there's two hops, right, to get there, right? And here's 1, 2, 3, 1, 2. All right. So in this case, if I'm looking at these two ports and going, which ports are going to be designated, right? Well, look, if I count from here and I go 1, 2, right, that's already a root port. Right, this one is 1, 2. They're the same. So I have to look at the lowest bridge ID, in this case, the lowest MAC address, and we're going to break the tie. So the one with the lowest is actually the link to this switch. So this is going to be my designated port right here. Okay. Now I'm going to do the same thing in this case, I have a switch right here, and I go 1 hop. This one is 1, 2. So the lowest cost wins, right? That is, oh wait, I'm sorry. In this case, no, actually, in this case, we have, let's see, I have a root port right here pointing to the root bridge, yes. And then I have, I already have a designated port on that side, yeah. So there's that hop, okay. And then, so I don't have one here, sorry. So here's my 1, 2, 1, 2, 3, right? That's the shortest hop. And we're gonna put a D right here. So I have an R. Now let's think about this. In this particular case, I have 1, 2 hops there. I have 1, 2 hops there. Which port gets to be the designated port in this case? It's the same, right? 2 hops, 2 hops. Which one? We're going to look at, again, the lowest MAC address in this case. So 0 alpha 3B, 00B, 3B. This is the lowest. So this will be the lowest bridge ID. So there's my designated port. Now what ends up happening when I have I have, at least in this case, every link that doesn't point to the root bridge had a designated port, and that's what I want to see, right? So from that case, I start listing the ports that are other ends of those links as alternate ports. So here's my alternate port, and here's my alternate port. So what will happen now that we have defined the alternate ports is the alternate ports are going to get turned off. So that's off. I'm sorry, it's not turned off, but they're going to block the traffic. Block. So effectively what will happen is I will end up with these 2 links blocked. This switch will become basically the root of a tree. This one will also be blocked. Right? So that will give us a loop-free topology. Now, if I were to break any of these other links, then my alternate port would wake back up when it's required. We would run the spanning tree again, and we would come up with another solution to get this topology ready with loop free. So if there's any change in the topology, the spanning tree protocol runs again and gives us a new topology. So those are the rules that we go by in order to figure out which ports actually get blocked. And this is so repeatable. It happens the same way every time. And this is a little bit more of a complex example. So you could see it in action and say, well, what happened if things get a little more complicated? And it's just, you can actually go through that algorithm, elect the root bridge. We elect the root port on all the other switches. Then we elect designated ports on the other end of the root ports. And then we look for links that don't have connection to the root bridge and figure out which ports are designated. And then we look for alternate ports. And those are the ports that get turned off. If I had one of those little symbols for the red with the line through it, I would put it on all the alternate ports.